Hi everyone, let's take up a question on gravitation. Two planets have masses m and 16m and their radii are a and 2a respectively. The separation between the centers of the planets is 10a. A body of mass small m is fired from the surface of the larger planet towards the smaller planet along the line joining their centers. For the body to be able to reach at the surface of smaller planet, the minimum firing speed needed is. So we have two planets, one a smaller one and other one a larger one. The smaller planet has a mass of m, whereas the larger planet has mass of 16m. Let us join their centers. The radius of smaller planet is a and the radius of larger planet is 2a. The distance between the centers of two planets is given to us 10a. Now the question says a body of mass small m is to be fired from the surface of larger planet so that it reaches the surface of smaller planet. Between the two planets there is a point where gravitational pull of both the planets is equal and in the opposite direction. So this point is called as the neutral point where force is zero. Let us call this point as T and this point as C. So we will have to fire this body of mass m in such a way that it reaches the neutral point D. Thereafter, a smaller planet will pull it inside it. So first of all, let us find out this neutral point, the distance of this neutral point from the smaller planet. Let's say this is small r. So its distance from the center of larger planet would be 10a minus r. Since the gravitational pull from the both planets at this point D is equal, so we can write gmm upon r square equal to g 16m small m upon 10a minus r whole square. This gives us 10a minus r whole square equal to 16 r square. This can be written as 4r whole square. So we can solve it. 10a minus r equal to 4r. Rather equal to plus minus 4r. This gives us two solutions for r. One equal to r equal to 2a and other is minus 10 upon 3a. Since we have to find out the minimum velocity, so we have to select one of them accordingly. Since the first whole solution r equal to 2a is nearer to the larger planet, the second one r equal to minus 10 upon 3a will fall opposite to the smaller planet. So this would be relatively much away from the bigger planet. So let us select the first solution, r equal to 2a. So we got the neutral point at r equal to 2a. Now let us use the conservation of energy at point C and D. At point C, total mechanical energy at point C would be equal to total mechanical energy at point D. So at C we have kinetic energy of the body of mass small m, half mv square. We also have at this point potential energy due to larger planet as well as potential energy due to smaller planet. So potential energy due to larger planet would be minus G16m small m upon 2a, and then potential energy due to smaller planet Gmm upon 8a. This would be equal to total mechanical energy at point D. At point D, this body of mass small m is not required to have any kinetic energy. It has to just reach the point D. Thereafter, the smaller planet will pull it inside. So, at this point D, we have potential energy from the two planets only. So for the larger planet, the potential energy at this point D would be equal to minus G16m upon the distance. This would be equal to 8a upon 8a, then minus potential energy due to smaller planet Gmm upon 2a. Let us solve it. This gives us half mv square. Let us add them. This will become minus 65 Gmm upon 8a. Let's add these two also. It will become minus 20 Gm capital M small m upon 8a. So this gives us small m cancels everywhere. So we are left with v square upon 2 equal to this is equal to 45 Gm upon 8a. So this can be written as v square equal to 2 into 45 Gm upon 8a. This gives us 45 Gm upon 4a. If we solve it, we will get 3 upon 2 root of 5 gm upon a. This is the minimum speed required.